Okay, let's take a look at a free response question involving several theorems of algebra and calculus. It's just strictly from a table. So these can be very tricky, but we're going to go through some steps here. Hopefully you'll kind of recall some of this and catch on pretty quick. Anyways, you have two functions, f, and they gave you the derivative of f, and there's g, and the derivative of g at the x values of 1, 2, 3, and 4. And they give you some key information here. They tell you that f and g are differentiable for all real numbers, and g is strictly increasing. So we might use that information. If g prime is strictly increasing, that tells us that g prime is always going to be positive, and you can see that from the chart here that these values are all positive. So that may come in handy in a little bit. And they also define a second function down here, h, which is the composite of f of g, and it's also minus 6. So let's just dive into part A, and notice that here they're asking why there must be some value in between 1 and 3 such that h of r is equal to a negative 5. So notice that this is not the derivative, this is just the function. So let's take a look and see what h is equal to at the endpoints 1 and 3, and we'll see if that won't recall a formula or a theorem that we can use here. So let's just define it. Let's do h at 1. So h at 1 is f of g of 1. Let me erase that and try that again. We have f g of 1 minus 6. Okay, so these composites that are in tables, they can be a little bit tricky, but let's just go in here and define what g at 1 is. So here's 1, and g at 1 is equal to 2. So we can replace this with f at 2 minus 6 and see what that equals. F at 2 is right here, and that's equal to 9. So we have 9 minus 6, or 3. So h at 1 is equal to 3. And we'll do the same thing for h of 3. And h of 3 is equal to f composed with g and minus 6 again. So now we're going to go down here to g at 3. G at 3 is equal to 4. So that becomes 4. F at 4 minus 6 equals, well, there's 4, and f of 4 is a negative 1 minus 6 equals a negative 7. So that's what h at 4 is equal to. So these two pieces of information, h of 1 is equal to 3 and h at 4 is equal to a negative 7. So they want us to guarantee that there is at least some value in between there that equals a negative 5. Well, the fact that it's differentiable tells us that it's continuous on that range as well, right? So the fact that it's continuous, that means that if you start off at 3 and then you drop down to negative 7, then it has to hit negative 5 at least once in there. So how are we going to justify that? Well, let me erase this part right here. We already know the value here, right? F of 4 is equal to negative 7, so by by the intermediate value theorem. Intermediate value theorem states that if a function is continuous, on, in this case, from 1 to 3, and if h of 1 is equal to negative 3, and that's certainly not h of 4, is it? Should be h of 3 right here, sorry about that. And h of 3 is equal to negative 7, and h of 3 is equal to negative 7, and there exists a number r on that same interval such that h of r is equal to negative 5. Okay, so that's a nice little problem. Basically, some of the key things that you want to mention is that the function is continuous on the interval, state what the values are, and then state that the intermediate value theorem guarantees that there has to be some value that's in between the endpoints. So we started off at 3 and we went all the way down to negative 7, so it has to hit negative 5. Alright, let's move on to the next one, part B. And the nice thing about this problem, I think, is that they're asking you about the same value, so you don't have to calculate the h values again. So let's see, part B. Part B says explain why there must be a value c such that the derivative in between that same value is equal to a negative 5. So this looks like the mean value theorem. So the mean value theorem. And what does the mean value theorem tell us? It tells us that if the function value of b minus the function value of a all over b minus a, so this is the average rate of change, has to be equal to that same value for some number in between b and a on the open interval, and that is only guaranteed if it is continuous and differentiable. So you have to discuss continuity and differentiability, which is given to us in the problem. We don't have to prove it because they told us that it's differentiable, therefore it has to be continuous. So we are going to mention that in our explanation. So it looks like this is the AROC, average rate of change, which is just the algebraic calculation of slope, right? Well, we already know what h of 3 and we know what h of 1 is, so we can just basically write h of 3 minus h of 1 all over 3 minus 1, and we can just set it up 3 let's see if I can write this correctly. We have h of 3, which is a negative 7, subtract 3 all over 2, so that's a negative 10 over 2, which equals a negative 5. So we have no way of figuring out exactly what that value is, because I mean it's just in this little range right here. We don't have to show that actual calculation, but we basically can say at this point, you know, by the mean value theorem, we can state that if the average rate of change is equal to negative 5, then there must be a derivative in between that range of 1 to 3 where the derivative is also equal to negative 5. So you need to discuss continuity and the fact that it's differentiable. And if it is continuous and differentiable, and that means that there has to be some derivative in there in which it equals -5. And so you'll talk about continuity on the closed interval from 1 to 3 and differentiable on the open interval from 1 to 3. And since that's given to us, then you can say that by the mean value theorem there has to be at least one derivative on some c, and c would have to be in the open interval 1 to 3. So there exists some c on the open interval that satisfies that derivative condition. Alright, so let's take a look at part C. Whoops. Try the eraser again. Alright. Okay. I think I'm done with that. Let's see, we might need this room over here. Alright, part C says let w be the function given by w is equal to the integral of f of t dt, and they want us to find w prime 3. Well, this is the second fundamental theorem of calculus, which says that, w prime of x is equal to f of g of x, right? So this is not an x in here, right? This is the function, and we're basically swapping the t out for whatever's in the upper integrand there, that g of x. Well, we don't know that that's not just a plain x, so then we also have to multiply this by the derivative of x. So you have to apply the chain rule right here on this second fundamental theorem of calculus. So that's something that's overlooked often. So now they want us to find out what is w prime at 3. So we have f of g of 3 times the derivative of g at 3. And let's just start looking at this again. So the first part here, we have g of 3, and g of 3 is equal to 4. So the first thing is that g of 3 replaces that with 4. And let's see if we can figure out the derivative at 3, this part right here. So g prime at 3 is equal to 2. Alright, and back to black, f of 4 is equal to -1, right? So we have -1 times 2, which just equals -2. So I don't think there's any justification we have to do there. We just have to find the value of it. So it wasn't too bad, hopefully. Just remember this chain rule. It becomes very, very important right here. And if you don't apply that chain rule, then you will get the wrong answer on that one. So let's move on to D. D talks about the inverse function. So this problem has derivatives, has integrals, has mean value theorem, all kinds of good theories in here that they're testing you on in one question. So part D says that if g prime, or excuse me, the inverse of g is defined by that, and they want you to write an equation for the line tangent to the graph of the inverse when the inverse is equal to 2. So if this is the inverse x value is equal to 2. That means on the original function, which is g in this case, right? The x and y coordinates that are associated with that is y becomes 2, right? So all we're doing is switching the x and the y. So let's go up to the graph to the chart and find where g of x is equal to 2. So let's see, here's g of x. Let's see if I can slide that up a little bit. G of x is equal to 2 right here, and that's when x is 1, right? So on the original, we have 1 there. So that means that the inverse has a function value of 2, 1. So right away, we know we're going to write an equation. So remember, we're doing the inverse, right? So we have y minus 1 equals, we're going to put the slope in there, right, in a second. And this would be x minus 2. So now we need to recall some facts about the inverse. Remember, the derivative, well, we're using g, aren't we? So the derivative of the inverse at x is equal to 1 over the derivative of the original function, where we switch the x and y. So we're really going to use the y value for our original. So, well, excuse me, we're going to end up using the y value on our inverse, which is, we're not going to use the 2, we're going to use this 1 right here, right? So all we have to do to find the slope, and this of course would be our slope, it's going to be 1 over the derivative of g at the value of 1. So we're just going to go up to 1, and this, I didn't write the derivative sign, did I, right there? Sorry about that. So the derivative at 1 of g is equal to, whoops, looks like 5, right? So that's just going to end up being 1 over 5. So we're just going to insert our 1 over 5 right here. And if we were to clean that up, we could, or I think we can actually just leave it in point slope. But if we did clean it up, we would have y equals 1 plus 1/5 of x minus 2, which should suffice. Alright, well, hope you enjoyed this video on this. It's a little bit of a nice question because it asks you about several different theorems, and they don't give you an equation, which sometimes trips us up a little bit. So just slow down and take your time on this one, and good luck with some more practice.